Okay, hello everyone. In this video, we are going to discuss representation of Dirac delta function in a Fourier integral. How it is? We know that in general the complex form of Fourier integral of a function, suppose fx, is written as fx equal to 1 by 2 pi minus infinity to plus infinity e to the power minus I omega x d omega minus infinity to plus infinity f of t e to the power I omega t dt. This is your equation number 1, right? This equation number 1 can be rewritten as fx equal to integration of minus infinity to plus infinity f of t, then whole into 1 by 2 pi integration of minus infinity to plus infinity e to the power I omega t minus x into d omega whole into dt. This is your equation number 2. So here what I done, 1 by 2 pi I written over here, and e to the power I omega minus I omega x e to the I omega t written as like this, e to the I omega taken common t minus x. But as per the property of Dirac delta function, what we know, but as per the property of Dirac delta function, we know that fx will be equal to minus infinity to plus infinity f of t into delta t minus x dt. This is your equation number 3. So this is the one of the property of the Dirac delta function, that delta t minus x, if it will be operated over another function f of t and integrated with respect to dt, then this value will be directly f of x. That means suppose I am going to consider minus infinity to infinity this f of t, suppose tq delta t minus x dt is there. So this value will be f of t. Here this value will be f of x. That means instead of t we have to consider x. So this answer will be x cube. About this property we know well. Okay, this is your equation number 3. Now just to compare equation number 2 and 3 both the left hand sides of equation number 2 and 3 are same. So hence RHS of equation number 2 and 3 has to same. If it is so, then in the RHS of equation number 2, ft is there, here ft is there. So delta t minus x has to equal to with this value, that is your 1 by 2 pi minus infinity to plus infinity e to the I omega t minus x d omega. So by comparing, here you have to write, by comparing equation 2 and 3, we get what we get? We get delta t minus x will be equal to 1 by 2 pi minus infinity to plus infinity e to the power I omega t minus x d omega. This is your equation number 4. And here this is nothing but the so-called delta function inherently present in the Fourier integral. The heading is your representation of Dirac delta function in a Fourier integral. So this is the equation number 1 is nothing but your Fourier integral. So inherently delta function present inside this Fourier integral, and what is the value of that delta function? That is your delta t minus x, that is 1 by 2 pi minus infinity e to the power iota or I omega t minus x d omega is nothing but the delta function which is inherently present in the Fourier integral. Okay. So here you have to write, this equation represents the delta function which is present in a Fourier integral of a function. Fourier integral of a of a function. So if in your exam this question is asked, oftenly this question you can found 2 to 3 mark. So you have to write up to this much, up to equation number 4. Okay. Now if we are going to consider the x equal to 0, if x equal to 0 we are going to consider, then equation number 4 will be, that is your delta t, which will be equal to 1 by 2 pi minus infinity to plus infinity e to the I omega t d omega. Okay. So this function, equation number, this you can put this is the equation number 5 itself. So this is the representation of delta function which exists at any point on the x-axis. So this is your xy plane. So here this delta function, which is value is this one, or it is in the form of integral form, and exists at any point on the x-axis. Suppose this is your x point, so on the x-axis. So at this point this delta function exists. So it is represented as delta t minus x. If this delta function exists at x equal 0, then this can be written as delta t. Okay. This is your delta t. So here as delta t, if we are going to consider x equal 0, this will be delta t means at x equal 0, this is the delta function. That means delta function exists at x equal 0. So here this delta function is the function of t and x is your variable. So instead of x along x-axis we can consider the variation of t, and along y-axis variation of delta t. So at 0 this is your delta t. At any point on this x-axis or the variation of t-axis, suppose t equal to x at this point, this is represented as delta t minus x. These things already we know when we discussed the delta function. Okay. So thank you so much for watching this video. Thank you.